let's get to today's video. To spend our 10-15 minutes here chatting about something important, interesting, and relevant that is happening in our universe. A few concepts here need to be clarified a bit before we continue with this video. First is what string theory is. Well, string theory would be what we call a theoretical framework that was created to try to deal with some things, mainly with the idea of unifying quantum mechanics with relativity. All right, in string theory, elementary particles, like electrons, photons, quarks, among others, wouldn't be a point-like particle, but would be formed by tiny little strings. What does that mean? That they would have dimensions. They are, obviously, very small for us to observe and all that. However, what happens is the following. If, by any chance, string theory really holds up, and if strings existed there at the beginning of the universe, in the primordial universe, they could have grown in proportion and reached gigantic sizes, even the size of galaxies, but with a width that tends to zero. And this type of structure in the universe is known as the famous cosmic strings. They would be made basically of energy, and because they are very thin, with a width tending to zero, as I told you, the energy is highly concentrated. And the question here is this. If by chance I have cosmic strings in the universe, they would leave observable traces out there. And one of these observable traces would be nothing less than gravitational lensing. So, gravitational lensing, which is normally created by galaxies or galaxy clusters and so on, that create those little rings that cause that amplification. James Webb uses it a ton, Hubble uses it a ton. In fact, they would be the trace of cosmic strings. But since a cosmic string is this, let's say, one-dimensional object, it would duplicate images, very clearly through it. Basically, one image goes to the left, around the string, and the other goes to the right. So, astronomers think that one of the pieces of evidence for cosmic strings would be gravitational lenses. So, and from there, we have managed, since, for a long time, since string theory was created, researchers have been looking for candidates for cosmic strings. So, several of these candidates have emerged over the years, and many of them were ruled out, either because they were a pair of galaxies or because they were, let's say, perfect duplications in the images, and then astronomers report it as being the famous Einstein ring, that kind of thing. And in some situations, they are still investigating, because they could also be pairs of galaxies that generate all of this. So, the deal is this. We, don't have, right, let's say, the gravitational lenses, which would perhaps be the best evidence for the existence of cosmic strings. It's something that we say is not unequivocal, meaning it creates a lot of doubt about it. All right, recently, a group of researchers came up with another strategy, another way to find evidence of cosmic strings that would not be linked then to gravitational lenses, but rather to gravitational waves. That's right. This happens why? Because if cosmic strings exist and they are gigantic in the universe, they'd form under the attraction of gravity. This can end up causing distortions that can fit into a new configuration, and this reconfiguration would emit gravitational waves. Why? Didn't I say that the cosmic string has a lot of concentrated energy? When it did that, imagine you take the cosmic string and give it a twist. Since this cosmic string is very large and has a lot of energy, the moment you twisted it, it would generate gravitational waves. The problem with these gravitational waves is that they have gigantic wavelengths, and we don't have a method today to detect them. LIGO and Virgo, they detect other types of gravitational waves. But last year, we saw that whole process, that whole publication of the NANOGrav data. What is NANOGrav? NANOGrav is a big project that uses pulsars. So you have several pulsars scattered throughout the universe. Pulsars are very precise clocks. So these pulsars, they go on emitting their signals and in the gravitational waves. We would be able to detect, these gravitational waves of gigantic wavelength could be detected by the pulsars. We call this a pulsar timing array. Okay? So you take that time in you give it a little delay that it gives, a small delay in the pulses. You'll be able to detect it. That's what happens. Okay? So, what the researcher said is the following. That if you measure the distortions in the signals of pulsars from different directions, This can tell the gravitational waves stretched or not in the space between them. Okay? And they did, in fact, find such gravitational waves that would fit the description of cosmic strings. So, could be that we have managed, for the first time, to detect evidence of cosmic strings, which would not be the gravitational lenses, but the gravitational waves using the pulsar timing array method. Did you understand? I think that was more or less clear, right? All right. And then you might ask, okay, Sergio, we figured out then the cosmic strings, we've cracked this puzzle. And what the hell is that for? What am I going to do with cosmic strings? And that's where something extremely interesting comes in. One of the great dreams of humanity is to travel in time, right? Everyone wants to travel in time. You want to go there, maybe to the future, maybe to the past. If you go to the past with today's information, you can gain great, advantages in many areas and so on. So, time travel is something very interesting. Again, in general relativity, it's mathematically possible to travel in time. Mathematically, it's possible. We wouldn't have the technology. But all right, in the theory of the cosmic string, this would now be possible, not just mathematically. So here's the deal. Cosmic strings, you see, they are this phenomenon that we are getting to know now, right? And what basically happens is the following. If you could in the universe align, pay attention. So if you could in the universe align two cosmic strings, what could they do? They could create a loop, or basically something very similar to a wormhole, okay? They could create this loop very similar to a wormhole. Remembering that this loop, mathematically, is an exact solution to the equations, even to Einstein's equations, okay? And since cosmic strings, as we've already said, have a very large energy, they could distort, bend space-time. They could then create these shortcuts. And that's what is ultimately thought to be a wormhole, right? A wormhole, don't we think of it as a region that connects two regions of space? The cosmic string could be the solution for that. Look how interesting. And here's the thing. Imagine you're traveling between two planets, for example. Okay? If there were a cosmic string in the middle of all that, it would create a shortcut compared to traveling directly between the points. So, imagine you have a point here and a point here. You're going to travel between them, right? You've traveled between the points. If you have a cosmic string, the cosmic string creates a shortcut. If you took this shortcut and traveled near the speed of light, you would be able to arrive at your destination faster than a light ray traveling along the normal path. Imagine it's like this. Imagine you're going to travel to a planet. You're going to travel. So, that means you arrive at your destination and be able to see yourself packing your bag at your starting point. Look how crazy cosmic strings would allow for this. Why? Because they create this loop, they bend space-time, and by bending space-time, it turns into a shortcut, and through the shortcut, traveling at a percentage of the speed of light, you would get there first and traveling the normal route. And this would basically make you travel in time. What the researchers have shown in the articles is that if two cosmic strings travel in opposite directions and cross each other, they distort space-time in such a way that they create a time loop. If you travel around the two, you would then be able to go back in time. Look how crazy that is, okay? But of course, you would need a ship that travels at very close to the speed of light and things like that, but it's not a completely impossible thing. So, there you have it, an application of the cosmic string. The first thing is to find evidence of the cosmic string. Did we find it? Apparently, yes. Of course, more analysis is needed and all that. This whole NANOGrav business is still under analysis. Researchers are trying to understand behavior of very long wavelength gravitational waves, which is what NANOGrav provides us. They may have given good indications of the merger of supermassive black holes, things like that. So NANOGrav is one side that we need to analyze, using the pulsar timing array and see there. If we manage to detect strong evidence of the cosmic string there, that's one thing. And the other is to find these cosmic strings, connecting these points in the universe, and then using them to travel in time. Because cosmic strings would, yes, be a beautiful solution for making time travel happen. Does it seem like a lot of craziness for a Saturday night? It's not that much. Take a look. I'll leave the links in the description for you to delve deeper if you want. And this was the video I wanted to bring to the channel for you now. I hope you liked it. If you liked it, you know the drill. That slap on the big toe, that flying kick with everything to the chest of the like button. That helps the video and the channel gain relevance a ton. Never forget the YouTuber package. Share, favorite. Subscribe to the channel if you're not already subscribed. Leave in the comments whatever you want to know. We're in this together, day in and day out, in the fight against bad science communication in Brazil, and against the anemia in the communication of astronomy in our country. Once again, my name is Sergio Sacani. I'm the editor of the Space Today blog, and you have just watched another Space Today TV. I'm out.